Okay, everybody, 5.3, we're going to do number 10D, okay? So this is solving radical equations. This one has two separate radicals, so you're going to have to square both sides probably a couple times to get rid of both radicals, okay? And you might end up with a quadratic in the end, and you have to solve it specifically like you do for quadratics. So, all right, let's see here. What have I got? You there. All right. So what you can do, and again, this is what I suggest. I would suggest getting one of the radicals all by itself on one side of the equation and everything else to the other side. You can, though, if you want, you can square both sides right from the beginning with both radicals on the same side. I wouldn't suggest it because you're foiling a bunch of radicals and you have a lot of opportunity to make a mistake, but it's up to you. So I would do this. Okay, you can do that and you get the same answer. I would just do this and take one of these over to the other side so that you have root x plus 19 all by itself equals 7 minus root x minus 2. Okay? Because what you're going to have to do is you're going to have to square both sides. So when you square both sides, you just have a single term here. You do have a binomial here, but at least one of them is just a constant, so you're not two binomials. A little bit easier. So this is going to simply give us x plus 19. When we square a binomial, remember, don't just square 7 and square this one. No, you got to do FOIL. So it's going to be, really, it's going to be like this times itself, right? Oh boy, my computer might crash here, just beware. So it's going to be 7 times 7 is 49. It's going to be minus 7 root x minus 2 minus another 7 root x minus 2. So that's minus 14 root x minus 2. That's when we do the outside and the inside. And then finally it's going to be plus this times itself, which is just x minus 2 with no radical there. Okay, is everybody good with those first kind of two steps there? And the distributing, yeah? You're okay with that? Okay, so I just have one radical here left, so I'm going to isolate for this radical here now. And you can keep the 14 if you want, doesn't matter. So I'm going to get everything over to the other side. So this 49's got to go over as a minus 49 over here. This has got to go over as a minus whatever. So let's do all that. So I've got x plus 19. I've got minus 49 now. This I'll just keep, so negative 14 root x minus 2. And then I'm going to also subtract an x here, and I'm going to add a 2 to that side to get rid of that. So if I put this all together, 19 plus 2 is 21. Minus 49 is what? Negative 28. And the x's are gone, so negative 28 equals negative 14 root x minus 2. Okay. So at this point, a good idea to get the radical all by itself. Why? Because you might think about what we just talked about and you might say, oh, I have a radical and I have a negative value on this side. Bad news. I can't do it. No solution. No, not no solution, because you also have a negative on this side. So good idea to get the radical by itself again. Like if you want to square this, knowing that this is negative and this is negative 2, you can just square this, but if you divide by, watch this, just divide by negative 14. This is kind of nice because this gives us what? Exactly 2. Okay. So this is, it's simplifying really nicely now. So if I square both sides, or you can actually maybe use your lightning fast brain from here and say, okay, this has got to be square root of 4 to make this 2, right? So x has got to be what? Be 6? Okay, so let's figure out if we're correct on that. Let's square both sides. 4 equals x minus 2. Add 2. 6 equals x. All right.
Show that last step, or can we do it?
You can do it from here, I guess. Just give me x equals 6. Yeah. It's always a good idea to show all your work, like squaring the last step, but it won't take you much time. So, folks, please let's check to make sure that this is not an extraneous root. Remember the extraneous root? Maybe that's not allowed. Maybe this answer is not actually real. Let's just see. So 6. Okay, so I'm going to check over here in blue. So root 6 plus 19 plus root 6 minus 2 should equal 7. So root 6 plus 19, that's root 25, plus root 4 equals 7. This is 5 plus 2 equals 7. Boom. It works.
So it would not equal out if it's extraneous?
Right. So if you have to reject a possible solution, when you check, you would get a negative maybe underneath here. That's what you would get. You would get 5 plus 2 equals negative 7, let's say. You'd be like, okay, something doesn't work there. So that's how you would know. Yeah. If it doesn't exactly equal each other, you got problems. And then you go back and check and make sure you didn't miss a negative sign or something. But yeah, that's why you check. If this works out, chances are you've done everything right and you're good. Okay, 10D, good?
We do 8A.
8A as another one, probably. This one right here?
Yeah.
Okay. I didn't do this one yesterday? Looks familiar, no? Didn't do it?
Wait.
I don't know. Maybe not. 8A. Let's put it down here somewhere after 5. We'll do 8A. All right, solve the radical equation. Okay, so once again, I would suggest that you get the radical all by itself. So we're going to minus 5 from both sides. This is going to be root 3x minus 5 on the left side and x minus 5 on the right. So how do we get rid of a radical? A square root, we square. So that's a valid operation to do to both sides of an equation. So take the whole side. Don't square individual terms, remember? You gotta square the whole side. So this is going to be square and square root, cancel each other out. It's 3x minus 5. This is going to be
X squared minus 10x.
x squared minus 10x plus 25. Very good. Let's get everything over to the same side because this is a quadratic. I'm not going to be able to isolate for x. I have to solve it like a quadratic. So we're going to have 0 over here. I'm going to have x squared. Negative 10x minus 3x is negative 13x. And then 25 plus 5 is 30. So opposite sign, eh?
Or you complete the square.
Yeah, so you can do quadratic formula. You can, complete the square is kind of I would say that should be your last option. Because you might have fractions, it's a little bit tougher to, So if you can do factor by sight, zero product principle,
Okay.
and then quadratic formula probably be your next option, and then completing the square or graphing if you have that option. But this one here, like the two numbers that multiply to 30 and add to negative 13, that's like 10 and 3, right? 10 times 3, negative 10 times negative 3. So this one, you might want to say, I can factor this by sight pretty easy. So negative 10 times negative 3 is positive 30, and you add those, you get negative 13. So now x equals 10 and positive 3. So we have two options, and again, like I mentioned before, the math that you're doing, okay, from here, this is the math that you're doing. It has no idea what your original question is. So you always have to check your answers because we're using math every step. We're using math and we're doing our rules. We're input output. We're simplifying. We're doing all this fancy stuff, all the math stuff. But the answers that it gives, it has no idea what your original question is. So you have to check yourself to make sure that both of these are real solutions. So let's do that. So if we check over here, I'm going to have 5 plus, let's check the 10 first. 3 times 10 minus 5 equals 10. So that's 5 plus 30 minus 5 equals 10. It's looking pretty good here. Root 25 equals 10. Yeah, 5 plus 5 equals 10. That's good. Okay. So let's check 3 now. Let's check 3. So I'll do that on the same screen here. This is going to be 3 times 3 minus 5 equals 3. That's 5 plus 9 minus 5 equals 3, right? So that's 5 plus root 4 equals 3. 5 plus 2 equals 3. Wait a minute. Did I do something wrong there?
No.
5 plus 2 doesn't equal 3. So does it look like 3 is an extraneous root?
Wait, shouldn't it be plus or minus?
Uh,
But we're only using. Oh, we're only using the one.
yeah, no, for this, yeah, so because this is in the question, again, this is kind of our rule. If it's in the question already, you always are dealing with principal roots, the positive. Yeah. If you have to take the square root in the context of a question in order to solve, then you have to take into account both positive and negative, yeah. But even so, if we were to do this negative, that would be -9 plus 5, so you'd have a root -4 problem. So no good, right? That wouldn't work. Okay, so what I'm going to do is I'm going to to double check this now, I'm going to graph this, okay? Because we could graph this to find the solution. Wait a minute. Have we not talked about this chapter? Oh, okay, that might be a pre-cal 30 thing that we'll work with, but hey, I'll show you now. You guys are pretty brilliant. Give me a second. Okay, so here, if I graph the left side of the equation and graph the right side of the equation, the solution will be the x value of the intersection point. We'll talk more about this in pre-cal 30, apparently. But this radical graph, the root graph here, looks like this. Yes, it's like a half of a sideways parabola. And y equals x is this blue line here. So notice that there's only one intersection point. Okay? Now, if this graph were to continue on like this, it wouldn't be a function, but if this graph were to continue on, it would intersect up right about 3. So in reality, though, this is not allowed. The 3 is not allowed. So there's only one intersection point. So that's why it's extraneous.
Whoa.
Yeah. Whoa, math. Awesome. Okay, so final answer, we reject 3, so x equals 10 only. All right, does that help with 8 there? Good, no? All right. 5, are you both wondering about 5? You could probably do 5.
It is the way it is. It's like.
5. Let's see.
Yes.
Oh, okay, here's the question about the extraneous.
Exactly.
All right, say that. Let's say how 5. Oh, do I have 5 up here already? Come on, computer. Oh, I do have 5 up here already. Look at that. Okay, gonna make this bigger. Can I? Yeah. Okay. All right. Okay. Here's number 5. Let me explain number 5. In the solution to k plus 4 equals square root of -2k, identify whether either of the values k equals -8 or k equals -2 is extraneous. So identify whether these might be solutions that are not allowed. Explain your reasoning. So 2 ways you could approach this. You could go ahead and plug -8 in for k, like I did right here, and you could evaluate both sides and see if they're equal. So this would be what? -4 equals square root 16. Uh-oh. If we have a principal square root equaling a negative number, that's bad news. So that actually doesn't work. Why? Watch this. -2k, because it's underneath the radical sign, has to be greater than or equal to 0. And if we isolate for k, that means that k has to be less than or equal to 0. Okay? So -8 falls into this branch, but you still have to check it. Okay? So anything that's over 0 definitely wouldn't work. But we still have to check both of these. All right, what about -2? You simply put -2 in instead of -8. And you get +2 equals root +4. Ooh, yeah, principal root. That looks like that might work.
So you've never ever used positive or negative square root?
So again, if you take the square root when solving an equation as an operation to find x, then you do have to account for the positive and negative. If it's a root that is already embedded in the equation, there comes with it a certain number of restrictions there. And so we're only dealing with the principal root. And Yeah, beyond that, I don't have a real great explanation beyond that, but that's the rule that I tell the students, that's the rule I live by. If you're taking the square root, if you actually write the square root for the first time in the middle of a question and you're trying to solve for x, then that square root has to be plus or minus, you have to consider both. But if it's an actual radical equation where that's already in there, then that has to, that quantity has to equal only the principal root, only has to equal positive. Because as it turns out, if it equals something negative, that's an extraneous root. So yeah. Now again, you could graph this side and graph this side separately, and then wherever they intersect, that will be your k value. The x value of that intersection point will be should be your solution. So I can try that for you if you want. K plus 4, okay. Okay, so y equals k plus 4, and k is just be our variable, and then the square root of negative 2k. So y equals square root negative 2k. Okay, so here we go. We have one intersection point here, looks like, on this graph, and that's at negative 2, 2. So it looks like negative 2 is a solution, because you always look at the x value here, okay, or in this case the k value. And negative 2 was the one that worked. So negative 2 is good. Negative 8, no good. So k equals negative 8 is extraneous. Might need a few minutes to let that sink in. I'm not sure.